NASA nuclear propulsion concept could reach Mars in just 45 days. NASA selected a nuclear propulsion concept for Phase 1 development as part of its Innovative Advanced Concepts (NIAC) program for 2023. The Nuclear Thermal and Nuclear Electric Propulsion (NTP/NEP) concept is a new class of bimodal nuclear propulsion system that uses a wave rotor topping cycle, as per NASA. The scientist behind the proposal, Professor Ryan Goss from the University of Florida, believes it could reduce travel time to Mars to a mere 45 days. If the technology does work as planned, it could drastically reduce travel times to Mars and make missions to the Red Planet innumerably safer for humans. Is nuclear propulsion the future of human spaceflight? The new proposal, titled Bimodal NTP/NEP with a wave rotor topping cycle, is one of 14 selected by the NIAC for Phase 1 development. It received a grant to the tune of $12,500 to research and develop the technology required. NASA has a long history of considering nuclear propulsion for spacecraft, according to Universe Today. This includes the nuclear engine for rocket vehicle application, NERVA, concept, which was successfully tested but then defunded around the same time the Apollo era came to a close in 1973. More recently, NASA also tested nuclear propulsion concept technologies with Project Prometheus in the early 2000s. Private firm Ad Astra, meanwhile, which is run by former NASA astronaut Franklin R. Chang Diaz, completed a record 88-hour high-power endurance test of its Vassimer VX200SS plasma rocket at 80 kilowatts in 2021. Ad Astra claims its nuclear rocket technology could eventually take humans to Mars at speeds of 123,000 miles per hour, 197,950 km per hour. NASA's new nuclear propulsion concept. NASA's new NIAC grant recipient leverages two of the key concepts behind nuclear propulsion. Nuclear thermal propulsion, NTP, utilizes a nuclear reactor to heat liquid hydrogen propellant so that it is converted into plasma and channeled through a nozzle to generate thrust. Nuclear electric propulsion, NEP, meanwhile, uses a nuclear reactor to power a Hall-effect thruster, ion engine, with electricity. This, in turn, generates an electromagnetic field that ionizes and accelerates an inert gas to create thrust. Goss, who serves as the hypersonics program area lead at the University of Florida, combines the advantages of both NTP and NEP with his new concept. The engineer proposes a bimodal design based on a solid-core NERVA reactor that would provide a specific impulse, LSP, of 900 seconds. That is twice the performance of existing chemical rockets. On top of that, Goss also proposes using a wave rotor, WR, to further compress the reaction mass using pressure generated by the reactor's heating of the liquid hydrogen fuel. According to the engineer, this has the potential to deliver thrust levels comparable to that of a NERVA-class NTP concept but with a higher ISP of 1400–2000 seconds. Combining this with an NEP cycle would produce even higher thrust levels. Shorter travel times are vital for the well-being of astronauts. What all of that means is that Goss's concept could drastically reduce the travel time to Mars for future astronauts. Using existing technologies, a crewed voyage to Mars could take about 6 to 9 months to reach the Red Planet. So, reducing the travel time to about 45 days would mean Mars missions could last months instead of years. This is vitally important as long missions to Mars would expose astronauts to high levels of radiation that could prove deadly. Not only that, the effects of microgravity on humans for such a long time period would also have negative health implications, meaning there is a strong incentive to reduce Mars mission times. Other concepts awarded a grant by NASA's NIAC program include a hybrid aircraft concept called Titan Air that could collect samples from the seas of Saturn's moon Titan. A concept for a lunar pipeline could also improve the efficiency of oxygen delivery for NASA's upcoming Artemis moon missions. The space agency has posted a full list of the impressive space concepts it is considering as potential game changers for astronomy, Earth science, and human space exploration. Let's talk on health challenges in space. Long-duration space missions pose several health challenges for humans. Here are some of the key concerns. Microgravity effects. Extended periods of weightlessness can lead to various health issues. Astronauts experience muscle atrophy, muscle loss, bone density reduction, and cardiovascular deconditioning. These changes can affect their physical performance and increase the risk of fractures and orthostatic intolerance, problems adapting to gravity upon return to Earth. Vision impairment. Some astronauts develop visual impairments during long-duration missions, known as spaceflight-associated neuroocular syndrome, SANS. It involves structural changes in the eye and can lead to decreased visual acuity. The exact cause is not fully understood, but it may be related to altered fluid distribution in the body. Radiation exposure. Astronauts are exposed to higher levels of radiation in space due to the lack of Earth's protective atmosphere. Long-term exposure to cosmic rays and solar radiation can increase the risk of cancer, cataracts, cardiovascular disease, and other health issues. Protective measures and shielding are essential to mitigate these risks. Psychological effects. Isolation, confinement, and the psychological stress of long-duration missions can impact astronauts' mental well-being. Factors such as social isolation, monotony, and the distance from family and friends can lead to mood disturbances, sleep disorders, and impaired cognitive performance. Effective support systems and countermeasures are crucial to maintain mental health. Immunodeficiency. The immune system can be affected in space, potentially leading to decreased immune function and increased susceptibility to infections. Research suggests alterations in immune cell function, changes in the microbiome, and reactivation of latent viruses. Nutritional challenges. Maintaining a balanced diet in space is challenging, and astronauts may face difficulty meeting their nutritional needs. Food options must be lightweight, non-perishable, and nutritionally dense. The limited variety and potential for monotony can affect appetite, leading to inadequate nutrient intake. Sleep disruption. The space environment can disrupt the natural sleep-wake cycle of astronauts due to factors such as altered light exposure, noise, and changes in work schedules. Sleep deprivation and disturbances can impact cognitive function, mood, and overall well-being. Addressing these health challenges requires ongoing research, technological advancements, and comprehensive countermeasures to ensure the well-being of astronauts during long-duration space missions. NASA has been exploring the concept of nuclear propulsion as a means to significantly reduce travel time to Mars. Traditional chemical propulsion systems used in current spacecraft are limited in speed and efficiency, resulting in lengthy journeys lasting several months. However, with the development of nuclear propulsion, NASA envisions the possibility of reaching Mars in just 45 days. Thanks for watching. Please subscribe, share and comments. Stay connected for more updates.